So first of all, we'll just glance what is cell division, and after that we'll go to some questions. Now we'll go to the whiteboard. Cell division. Now, here you are knowing the somatic cells and allosomic cells, autosomes and allosomes. The somatic cells, other than sex cells which are present in our body, we are calling them as somatic cells, and the cells which are related to allosomes are the sex cells, then we are calling them as allosomic cells. Now here the cell division is of two types. One we are calling it as mitotic cell division or mitosis, and another one we are calling it as meiosis. So, two types of cell division you are observing. One we are calling it as mitosis, and another one we are calling it as meiosis. So, mitosis, here the different stages you are observing. First it starts with interphase, then comes prophase, metaphase, anaphase, and telophase. So, four divisions you are observing, including interphase, that is the 5 divisions. In case of this, cell is becoming ready to divide, in the sense the storage of food material, everything is done in interphase. The cell enlarges in size, okay, and the chromatin is somewhat thicker. So such a type of ready phase, what is that? You are calling it as interphase. I am writing it as ready phase. So next one is the prophase. In case of prophase, just see, if suppose this is the cell, here the nuclear envelope you are observing, nucleolus you are observing, and here a lot of hairy thread-like structure what you observe, you are calling it as chromatin. So I am writing it here, chromatin. Then this chromatin undergoes maximum condensation, and then slowly late prophase, this is in the early prophase, cell enlarges, nucleus enlarges, nucleolus is conspicuous, and the chromatin whatever is there, it undergoes condensation, and finally the cutting of the chromosomal bits you are observing. Then what happens? In case of nucleus, nucleolus slowly disappears. Then chromatin forms of bits, they are irregularly distributed along with centromere. And then whatever the centrosome is there, okay, or centriole what we are calling, this centriole divides and slowly it forms the spindle fibers. Then in the late prophase, the spindle fiber enlarges and this centriole, it moves to the opposite pole, and then the spindle fibers are produced here. And then the chromosomes, they slowly come near towards the spindle fiber. This is in case of prophase. And nuclear envelope disappears, nucleolus disappears. Those chromosomes are scattered here and there in the cell. And then this is regarding prophase. In case of metaphase, what is happening? Just see, these are centrioles forming spindle fiber, and whatever chromosomes in case of prophase, they are scattered here and there. Okay, they get attached with the spindle fiber. And when attachment is taking place, attachment will be very irregular. Everywhere the attachments you can see. And then finally, in case of metaphase, all these chromosomes, see, these are the poles forming spindle fiber, and chromosomes, this is the central plate. All chromosomes are gathered here, and they are forming a metaphase plate. So, in this way, all chromosomes, they are organized in the plate form. What we are calling it as a metaphase. And then metaphase breaks. 50% of the chromosomes move towards the upper side and 50% they are coming downward side. So, see, if this is the pole and they are forming the spindle fiber, then metaphase plate breaks equational division, what it is taking place. There, the plate is breaking, chromosomes start moving towards the opposite poles. And the chromosomes, they leave the central plate, but they are not reaching to the poles. They will be in between the pole and the central plate. And they are forming two bundles. Then you are calling it as anaphase. Then finally, these are the poles, these are the spindle fibers. Now, all chromosomes, they are gathering around the pole. So, here also, they are gathering around the pole, and they are forming two bundles. Then you are calling it as telophase. Then after telophase, here, if suppose this is the cell, the chromosomes, they are forming two bundles. Now, cytokinesis is taking place. From the end towards from the periphery, the notch will be formed, and that notch slowly moves at the center and joins. And so, the continuous plate is formed, so as a result, the cytoplasm breaks. Half of the cytoplasm comes towards the lower side and half goes to the upper side. This process, you are calling it as cytokinesis. So, division of the nucleus, you are calling it as karyokinesis. Then, division of the cytoplasm, you are calling it as the cytokinesis. And then, the cell wall formation and all the things they are taking place. And after that, two separate cells are produced with all inclusions of the cell, and single cell get converted into two cells. That process you are calling it as mitosis. But here, one thing you have to remember, whatever chromosomal number is there, the chromosomal number is doubled, and these chromosomes are equally distributed in the daughter cells. So as a result, in mother cell, whatever the chromosomal number is there, the same chromosomal number is observed in the daughter cell. So we are calling mitosis as equational division. Now, so what is mitosis? How we are going to define mitosis? Mitosis is a process in which the chromosomal number is doubled and it is equally distributed into the two daughter cells. So single cell get converted into two cells. This process we are calling it as mitosis. It is usually taking place all over the body other than the sex cells. So mitosis is very important. And one parts whatever are there in the body, okay, the scratches and other things, whatever the wounds are there, all those are healed with the help of mitosis. The growth, the development, everything is taking place with the help of mitosis. So in this way, you are observing mitosis. Now coming to meiosis, in case of meiosis, so here meiosis is divided into two types. Here we are calling it as meiosis 1 and another side we are calling it as meiosis 2. In case of meiosis 1, we are calling it as prophase 1. So prophase 1, it requires a longer duration in case of meiosis. Meiosis 1, prophase 1 is very important in meiosis. Usually in the examination, the questions are asked for full mark question as well as short mark questions. In CET also, so many questions will be there on this prophase 1, meiosis 1. So prophase 1 is again divided into 5 parts. That is lactotine, zygotine, pachytine, diplotine and diakinesis. So meiosis 1, prophase 1 is divided into 5 parts: lactotine, zygotine, pachytine, diplotine and diakinesis. Here pairing of homologous chromosomes, shortening of chromosomes, chiasma formations, crossing over, exchange of genetic bits, gene exchange, everything is taking place. And after this, it is entering into metaphase 1. Then anaphase 1, finally telophase 1. After telophase 1, again the chromosomes internally they are forming interphase and then they are entering into meiosis 2. Okay, after telophase 1, it undergoes to meiosis 2. In meiosis 2, here again the repetition: prophase 2, metaphase 2, anaphase 2 and finally telophase 2. Then it undergoes cytokinesis. The division is taking place. Say for example, this is the cell. Here the 4 cells are taking place. So single cell get converted into 4 separate cells. So as a result, whatever chromosomal number is there, the chromosomal number is reduced to half here. So we are calling meiosis as the reduction division or reductional division we are calling. So it is reductional division. The single cell get converted into 4 cells. All these 4 cells are haploid in nature. So the diploid cell get converted into haploid cell, single cell get converted into 4 cells, and that is restricted to allosomic cells or sex cells. So the meiosis is very important, and they are forming the pure type of gametes in male and female. Later, these gametes combine together to form a diploid zygote. And later, the zygote get converted into embryo and embryo. So, in this way, you are observing mitosis as well as meiosis. So, now we will go back to our questions. Now, this is Unit 4, Part 9, the cell. We are studying regarding the cell division. We will go to the first question. Now, the term meiosis was coined by, who has coined the term meiosis? We will go here, Hartwig and Van Beveren, Sutton and Boveri, Hofmeister and Waller, Farmer and Moe. Here the correct option is the term meiosis was given by Farmer and Moe. So option D, Farmer and Moe, is the right one. Next, coiling of chromatids in mitotic and meiotic division is coiling of chromatids in mitotic and meiotic division is. So the options: paranemic in both, plactonemic in both, paranemic in mitosis and plactonemic in meiosis. So plactonemic in mitosis and paranemic in meiosis. So option D, plactonemic in mitosis and paranemic in meiosis is the right answer. We'll move to the next. As there occurs more and more condensation of chromatin during cell division, there occurs, just see the options, increases, just a minute, okay, increase in heterochromatin, increase in euchromatin, differentiation of heterochromatin and euchromatin decreases, differentiation of heterochromatin and euchromatin increases. Here the option C, differentiation of heterochromatin and euchromatin decreases. This is the correct one. So option C is the right one. Next, condensation of chromosomes occur in. So condensation of chromosome, where it occurs? Just see. Prophase 1, prophase 2, anaphase, metaphase. So I told you, just we discussed, that is option A, prophase 1. Maximum condensation is taking place in prophase 1. Next one. The replication of nuclear DNA occurs in where the duplication of DNA is taking place. Just see. G1 phase, G2 phase, S phase, M phase. That is, in cell division, option C, S phase, that the replication of nuclear DNA is taking place. Next one, the role of meiosis. Formation of gametes, bringing haplophase, bringing diplophase, completing life cycle. Here, bringing haplophase. So, haploid gametes are produced. It is a reduction division. The gametes should be haploid. then only they can produce diploid zygote. So for that purpose, option B, bringing haplophase is the correct answer. We'll move to the next. The number of DNA in chromosome at stage of cell. Just see, at stage of cell cycle it is. Just see, 1, 2, 4, 8. The number of DNA in chromosome at stage of cell cycle, it is option B, it is 2. So 2 is the correct answer. Next, which stage connecting link between meiosis and meiosis 2? Meiosis 1 and meiosis 2. So connecting link between meiosis 1 and meiosis 2. That is interphase 1, interphase 2, interkinases, anaphase 1. It is the option C, interkinases. It is the connecting link between meiosis 1 and meiosis 2. Next one. Which of the following stage is affected by colchicum? So, following stage is affected by colchicum. Just see, A, metaphase, B, prophase, C, interphase, D, anaphase. It is affected by option A, metaphase. So, metaphase is the correct answer. Next one. G0 stage of cells in eukaryotic cell cycle denotes G0. Okay, what it is denoting? Option A, checkpoint before entering the next phase, pausing in the middle of the cycle to cope with the temporary delay. C, death of a cell. D, exit of cells from cell cycle. So, G0 stage cells in eukaryotic cell is denoting exit of cells from cell cycle. So, the cells from the cell cycle, it is exiting. That is G0 we are calling. So, option D is the correct answer. Next. Synapses is pairing on. What is synapses? Okay, what pairing it is taking place? Just see. Any two chromosomes, non-homologous chromosomes, acentric chromosomes, homologous chromosomes. So, homologous chromosomes, they are pairing, they are coming side by side, and the same type of chromosomes, they are making a pair. That is called homologous chromosomes. So, synapses in between that, the synaptonemal complex you are observing, such a type of pairing itself you are calling it as synapses. So, homologous chromosome is the correct answer. Option D is the right one. Next. Mitosis occurs in, where mitosis is taking place? Haploid individuals, diploid individuals, both A and B, then in the bacteria only. So, mitosis is taking place in haploid as well as diploid. So, both A and B is the correct one. So, option C is the right one. Next. Spindle apparatus is formed during which stage of the mitosis? Here, prophase, metaphase, anaphase, and telophase. Actually, option B during metaphase. Whatever the spindle apparatus, spindle fiber formations are there, that completely formed in metaphase plate. So, here metaphase is the right one. Next, cycling is associated with which one of the following? Glycolysis, cyclosis, hemolysis, mitosis. So, cycling is associated with which one of the following? That is associated with option B, mitosis. Next one. For beaming dikinases, which one of the following would be a suitable material? Okay, which material is very suitable to observe dikinases? Just see, onion root tip, leaf of dicanthum, rat-tail, flubber bud. Here, the correct option is option B, flubber bud. In case of flubber bud, we can view dichanasus. Next one. Which is not the character of mitosis. Here, the options are given, which is not found in mitosis. See. Leptotein, zygotein, packaging, all of the above. So, which is not the characteristic of mitosis? Leptotein, zygotein, packaging, all the above. All the above are not the characteristic of mitosis. Because in prophase 1, meiosis 1, prophase 1, you can see leptotein, zygotein, packaging, diplotein, and dichanasis. So, this is not seen in case of mitosis. Next one. Synaptonemal complex is formed during, when synaptonemal complex is formed? Yes, see. Okay, now see, meiosis, mitosis, cytokinesis. It is not seen in case of meiosis. Synaptonemal complex is formed during. Okay, in case of meiosis, synaptonemal complex is formed. Next one. Synaptonemal complex was discovered by, who discovered this synaptonemal complex? Now, when it is discovered? 1956, 1950, 1935, 1980. 1956 is the correct answer. Next. Recombinant nodules are found during which of the following? Recombinant nodules. Okay, just see, anaphase, prophase, telophase, metaphase. It is found during option B, prophase. Next one. 4 daughter cells formed after meiosis are, just see, genetically similar, genetically different, enucleate, multinucleate. It is genetically different. Next one. So, here we discussed something about cell division and few questions we discussed. So, dear friends, go through the books, find some more questions, and that will be helpful to you. So, we'll start. Thank you.